Hello. In this lesson, we're going to talk about solving absolute value inequality, solving absolute value inequalities. Before that, so our goal here is to solve absolute value inequalities. Okay, so before that, we like to recap on solving absolute value equations. Okay, in the previous lesson, okay, so let me make font just a little bit smaller so you can see the whole thing. In the previous lesson, we talk about solving absolute value equation, right? We talk about how the functions can be used under the circumstances, right? While the output is given. The output is given. The output could be positive number, could be zero, could be negative. In each one of these cases, how do we solve these equations, right? We understand equations are if statement, okay? Equation is if statement. So in this case, we have input, right? So the input could be X and you know, whatever inside the absolute value, right? It produces an output, right? So this output could be, is known, okay? Output is known, and this output could be positive, zero, negative. In each one of these cases, right? What to expect? The function perspective and the definition perspective, right? So we did that for absolute value equation. And today we're going to talk about absolute value inequality. Okay, so absolute value inequality. Absolute value inequalities, there are a variety of cases. There are a variety of cases, right? Let's start with meaning. Let's start with meaning once again. Okay, so for absolute value inequalities involving absolute value, starting from the simple one, okay, starting from the simplest one yet. Okay, so I'm going to make the font just a little bit larger. Suppose we look at this absolute value right here, right? This is the basic function. This is the basic function. Absolute value inequalities typically have a variety of forms. So first of all, let's review what is the inequality. Okay, what is the inequality? Inequality are typically, you know, statement, okay, if statement. There are if statements. So inequalities, okay, are typically our statement involve greater than, okay, involve greater than, okay, so I'm going to enumerate these words, right? Greater than, right? Something is greater than something else, okay? So something is greater than something else. So this is one case. And in this case, we will have something on the left and greater than on the right and blah, blah, blah. Okay, something is greater than something else. Okay, so the quantity on the opening side of the symbol is larger if that is larger than the other side. And the other statement is that something is less than something else. Okay, and this symbol would be something less than something else. Okay, so these are the you know, inequality. Other inequalities will be the combination, right? A combination of greater than or equal to. Okay, so that's a greater than or equal to. Okay, so in this statement, right, the symbol would be greater than or equal to, right? So if I put this category, right next to greater, right? Greater than, this is greater and this is greater than or equal to. Be careful, the word connecting them is or. Okay, so let me make it or, I'm gonna make it uppercase, greater than or equal to. And for less than, of course, we will have, okay, we have right here, less than or equal to. All right. So the symbol, the respective symbol would be less than or equal to. All right. And there's another one. Okay, so I have greater than or equal to, less than or less than equal to. Okay, and the other case is not equal to. Not equal to. Not equal to. Okay, not equal to. Something is not equals to something else. Okay, in this case, the symbol is this. Okay, you have seen this symbol before. So something is not equal to something else. All right, so these are the cases of inequalities. And once again, inequalities, you guys have seen inequalities. Here, I will give you not only the definition perspective, but I also will give you the function perspective. Okay, so let's look at some example. Example number 1. Okay, the question would typically be saying solve for x. Okay, and you'll be given an inequality. And this inequality will be absolute value of x, say is less than, say less than 2. How about that? Right, less than 2. Now, what does that mean? Right? What does that mean? Well, it means that from the function's perspective, right? So meaning the function perspective. Okay, the function perspective. The function perspective basically say, oh, we have an input, and this input, we apply the function. Okay, we apply the function. So this is our function. Okay, this is our function. And our function is absolute value, and the output, okay, the output is going to be less than 2. What is the output? Right, we've seen the graph. The output means that it's a vertical, right? Input is horizontal from the origin. Output is the vertical from the origin, right? You have the same point of reference. So in this case, less than 2. The output are less than 2. So what does it mean the output is less than 2? Right? All of these, right? This is the input, output. Input, output. Right? Input, output. Right? Input, output. Right? So the input is measured from the origin, right? Input, right? Measured from origin, output. Input, output. So when we want the output to be less than 2, what does that mean? It's a 2 is the cap. 2 is the cap for all of these vertical lines, right? We don't want that output to be exactly 2, and we don't want it to be larger than 2, and we want them to be less than 2. So what are the possible output for this function? Well, the absolute value of any number is at least 0, right? So the output for this particular function, the absolute value, they're all going to be at least 0, right? For example, the input is 0, the output is 0. That is the smallest input we can expect. And all the output of our desire is going to be less than 2. And let's see, what are those, right? What are those? So well, what we can do is that we can draw a horizontal line. We're going to draw a horizontal line, right? So this is the number we cannot exceed. Any output that's higher than this one or equal to this one, they will not be our solution. What are our solutions, right? So let's look at what are not our solution. This one is not, and this one is not, right? So those respective inputs will be out. Okay, how about this one? And this one is yes. And there are many in between. Yes, 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 but not -2, right? So not this piece, not exactly -2. You can see for all the input, we're looking for input such that their output are going to be what? Are going to be less than 2. So what are those, right? So if we clear up we clear the picture, we're going to remove those, right? Remove those that are not. So what do we have? What do we have? So all the output we can have, right? All the output that fits our desire will be just a little bit less than 2, right? A little bit larger than -2, right? And everything in between. So all of these inputs would give us less than 2 output. Does that make sense? I hope that makes sense. So that's what it is. That's what it is, okay? So let me draw the picture, okay? So in this sense, right? In terms of input, the input from -2, 0, we're gonna put a circle, right? You probably have heard this, circle. And another point, which is 2, 0 is also going to be a circle, and everything in between. And everything in between. All of these inputs whose output will be less than 2. Does that make sense? Okay, because in this question, it tells us if the output is less than 2, what are all the possible inputs? Okay, so let me clean this up, right? All the inputs that's between -2 and +2 and their respective output will be less than 2. Okay, and this question is asking us to solve all the solutions, right? So if this is true, if the output is less than 2, our task here, solving for x, is to find all possible solutions. Okay, all possible inputs, right? Inputs. Okay, or solutions, which are x, okay, such that their output is less than 2. Okay, so that's the nature of the question. So what will be the answer? The answer will be the description of all of these numbers that's in red, marked between -1 and -2 to +2, right? larger than -2, smaller than +2. Larger than -2, smaller than -2, smaller than +2. So -2 less than x less than 2 will be all the solutions. So that's the solution. That's the solution. Okay, that's the solution. So this is the function perspective. But how do you show work? How do you show work, right? This is how you show work. When you show work, you just write it down because you see mathematics is full of shorthand notation, right? And your next line is just, that's it. Just 2 lines, 2 lines. If you wish to draw the picture, great. If you draw the picture, perfect, right? And you may also draw this horizontal line. Okay, I would draw this horizontal line because we know the output, right? So this tells us that we don't want the output to be 2 or higher. We don't want the output to be 2 or higher. Okay, that's it. So how to show work? Just 2 steps. If you have the picture, great. If you don't, no big deal. Okay, if you don't have the picture and you express it correctly, that's okay too. So this is the function perspective. Okay, and I will also call this method, method 1, the first method. Okay, and the second and the next perspective, which is another method, method 2, solving the same inequality, solving the same inequality, is that we go by definition. Okay, we go by definition, right? I bring a picture here, right? Just look at the number line. Just look at the number line. Okay, we're not doing function, right? So we're not doing function. Okay, so if the absolute value of x is less than 2, and if the absolute value of x is less than 2, what is the meaning of absolute value? The meaning of absolute value of x, wait, okay, the meaning of absolute value of x, its meaning is the distance between, an unknown number x and origin, and origin 0. We don't know what x is, but we know where origin is. This is the origin, right? This is origin. And the distance to origin would just be, if I let me draw some, just some lines, right? The distance could be this piece, right? That's the distance. And that's the distance less than 2. And this is the distance. Well, that distance is larger than 2. So this number cannot be a solution. It cannot be -2 either. So this cannot be. It cannot be -2. Okay, so I'm going to have to put a circle here. I'm going to have to put a circle here. It cannot be 2 either because the distance cannot be exactly 2. Then you realize that all of these numbers, right? All of these numbers whose distance is between what? Between the number and origin is less than 2. So all of these numbers between -2 and 2 are solutions. All of these numbers between -2 and 2 are solutions, right? So with that, I'm also going to draw the graph. Okay, I'm going to draw the graph. And this graph we're going to draw is very similar to the picture we drew earlier. Okay, I'm going to put a red dot, but it's a circle. Okay, and everything in between. Everything in between. So this is the show of the solutions. This is the show of solutions. Okay, it shows that the distance between any number covered by the red solid line to origin is less than 2. Okay, so using definition, we will show the same steps, and the description, if you use a graph, will be such. And if you want to show work, if you show work, you can show the picture along with it. But if you don't show the picture, if you show this much of work, that's great. But if you don't show the picture, that's fine too. So it's just one step, but it has so much meaning behind it. It has so much meaning behind it. Okay, so this is a type of inequality. Okay, so let's just show the picture. You know, make the picture. It just makes things nicer. It just makes things more illustrative. Okay, so this is the solving inequalities for example number one. But what if we have another example, right? And this time it's going to be less than or equal to 1. What would that be? Well, less than or equal to 2, right? We've done equal to 2, didn't we? So less than or equal to 2, if we do the function perspective, what will happen? We're going to draw a solid line. We're going to draw the solid horizontal line. Okay, I'm going to draw the solid line. So in that case, the solid line, right? So -2, +2 will be solution, right? So in this case, I'm going to use dot instead of circle. Dot meaning it's included. Okay, the point itself is included. Okay, so if we want the output to be less than or equal to 2, right? The function perspective. Right? So we have the function, right? The absolute value, right? The absolute value, and the output is less than or equal to 2. So it can be equal unless, so it's really for all the solutions for less than 2, union all the solutions for equal to 2. So in that case, our solution would be what? Our solution would be -2 less than or equals to x and less than equals to +2. Okay, and the definition perspective, right? Method 2 on the definition perspective, right? So I'm just going to copy and paste on the definition perspective, right? It's like everything are being equal. The only difference for this case, right? It can be equals to 2, right? So this is going to be less than or equal to 2. So this is going to be less than or equal to 2, less than equal to 2. In terms of this graph, what will happen? The circle will turn into what? The circle will turn into dots. Okay, so that's going to be a dot. And that's going to be a dot. That's it. Okay, so this is for less than or equals to 2. Let's look at example number 3. Okay, so this time I'm asking you to solve for x again. Okay, I'm asking you to solve for x again. But this time I'm going to have absolute value of x is less than 0. Less than 0. Less than 0. What is the function perspective? What is the function perspective? Right, we still know the output, don't we? Right, we still know the output. the output instead of less than or equals to -2 or less than 2. And this time we want the output to be less than 0. So it's really the same narrative. It's just the requirement is slightly changed, right? The if statement is changed. If the output is less than 0, what are all the solutions? What are all the solutions? And the function perspective, what is the function perspective? Let's look at method 1. What is the function perspective? Right? We will look at the picture. Okay, I have the picture here. I have the picture. Right? For each input from this graph, we can identify solutions. We can identify solutions, right? And the solution, we know that a horizontal, vertical, right? All the verticals, right? If you look at all the verticals, right? All the verticals for this input, the output, right? This is the input and that's the output. And this is the, for 0, the input output is 0. Okay, so I'm gonna put a red dot there. Okay, with red heart there. And input, output, input, output, input, output, okay, input, output. Okay, so all of these are outputs. All of these are output. But if you want to say, oh, you say, well, once you know the output, you're gonna draw a horizontal line. Sure, we can draw a horizontal line. We're gonna draw this horizontal line. Okay, this horizontal line I'm drawing because it's less than 0. So I have to draw a broken one. Okay, I'm gonna have to draw a broken one. Okay, I'm drawing this broken horizontal line. Is there any of the output that is less than 0? You see, all of these are above 0, right? There's only one equal to 0. That's the smallest. So do you find a point? Do you find an output that is under the x-axis? Do we have an output like that for this function? Do we have an output like that, like less than 0? Because less than 0 it's a vertical image that's beneath x-axis. Do we have that? No, we don't. We don't. Okay. So what is the solution? I need the line to be vertical, to be to be broken, sorry. To be broken, sorry. I mean to be broken, okay? And so none of the vertical line is beneath this broken line. None of them is, no input is beneath it. So therefore, there's no solution. No solution. No solution, right? Because you can see the broken one is not supposed to, we should not have any output that's equal to broken one because we need to be less than. And for less than, there's no touch, right? And the other perspective, okay, actually I'm gonna combine method 1 and method. The other one is that also besides, right? If you look at for this function, what's the range? What's the domain and range? Remember that domain and range in one sentence, that the absolute value of x is always at least 0. And this is true for any real number, right? So for any real number, the absolute value of that number is at least 0. Of course, it will never be less than 0, right? It will never be less than 0 because these two are just opposite to each other. If this happens all the time, of course, this will never happen, right? If this happens all the time, its opposite will never happen. So there's no solution. So function perspective, we can look at the graph, we can look at the domain range. It tells us the same thing. How about method 2? Method 2, it tells us the same thing, okay? Method 2 tells us the same thing because the absolute value, okay? The absolute value of any number to origin. Okay, so if you insist to do method 2, right? If you measure the distance between any number to 0, you want that distance to be less than 0, and that's never going to happen, not in a million years. So this same statement stay true even when we use definition, Okay, so for that reason, right, then you can say thus the absolute value of x less than 0, right? If this is true, then there is no solution. I hope that makes sense. I hope you guys see the visual, see the definition, and really understand it. Okay, so let's look at another example. Example number 3 is done. Let's look at example number 4. Okay, so once again, it's solved for x. And this time, okay, we are given absolute value of x is less than or equal to 0. Wait, less than or equal to 0. Okay, less than or equal to 0. Less than or equal to 0. So from the function perspective, right? From the function perspective, do you think we have a solution? Do we have a solution? Right? So this is our function perspective, right? But this time is less than or equal. Could the absolute value of x less than 0? And we knew it cannot be less than 0. There's no solution. But or equal, right? This means less than or equal. Less than or equal. Less than, we have no solution. But equal, do we have solution when it's equal? Yes, we do, right? Yes, we do. So this picture, right? This picture, we will draw a solid line. We'll draw a solid line. Okay, we will draw a solid line. And there's one touch. There's one touch. Okay, there's one touch. And that one touch is the only one solution we have here. Is the one solution we have here. Okay, besides, right, if we quote the domain, a domain and range in one sentence, right, it could be less, absolute value of x is always greater than or equal to 0. And this one, less than or equal to 0. So there's one solution and one solution only in this case. Okay, so the solution in this case, right, what we have one touch, right? The output is less than or equal to 0. Less than 0 is impossible. Equal to 0, yes. And therefore the solution would just be what? X equal to 0. X equals to 0. Okay, then you say, how do you show your work? Do you just write down all of these? Well, this is how you show your work, right? If your professor asks you to show work and giving you this question, what do? Right, this is the question from your teacher, and your answer is what? Your answer is just x equals 0. You're done. Do you need to draw the picture? No, yes or no. You don't have to. If you draw the picture, great. If you don't draw the picture, it's not big deal either. But you should have this picture in your mind. Okay, you should have this picture in your mind. Okay, this is why we illustrate these questions. We illustrate these questions, right? So let's look at method 2. Method 2. Method 2, we use definition. We use definition, right? So what's the distance, right? What's the distance, right? The distance. So once again, let's look at the distance. Right? It's the distance between x, right? Between the x, which is input, or whatever you call it, and the origin. The distance between x and origin, 0, right? That's the definition of absolute value, the distance between x and the origin. And we want that distance to be what? To be less than 0 or equal to 0. For less than 0, we have discussed no solution. Equal to 0, yes, we have one solution out there. Okay, so this question, right? We have just one solution. We have just one solution, which is that dot. Okay, we just have one solution. And that one solution means that the distance between 0 and 0 is 0. Okay, this means, right? This means the meaning of absolute value of 0 means what? What does it mean? It means the distance between 0 and 0 is 0. That's what it means. Okay, that's what it means. All right, so we have talked about these examples, right? I hope you guys have the patience to watch it and really understand what I'm trying to teach you here. Okay, try to share with you here. So let's look at example number 5. Example number 5. And this time I'm going to have less than -2. Less than -2. Okay. The function perspective, right? So we still have that function perspective. Less than -2. Method 1. Less than -2, right? So we're gonna, this horizontal line will be drawn, but it's not going to be 0 this time. It's going to be -2. It's going to be -2. Okay, not -3, -2. And I will have a, I would adjust this to frame. So this is the, this is the absolute value. Yeah, we want the absolute value to be less than -2, right? To be less than -2. You can see this horizontal line does not touch the curve. This horizontal line does not touch the curve. What does that mean? This means that, what does that mean? Do you think there's any input whose absolute value is going to be less than -2? All of these absolute values will be what? Will be higher than -2, right? Therefore, there's no solution. There's no solution. Okay. Now, from the domain and range perspective, right? The absolute value of any real number is going to be at least 0 for any real number x. Okay. thus the absolute value less than -2 is not possible. Is not possible, right? You can see all these output you can draw, all the output solution. Summarize these cases. Let's summarize these cases. You can see that periodically summarize will clear our head and mind, clear our mind about the question at hand and really reflect on the meaning, okay? So in this section, we primarily discuss less than, right? And of course, we discuss less than, equal to. So these are the things we discussed. And next, after this summary and the examples, we're going to discuss greater than or equal to. Okay, so let's do one at a time. Okay, so in our summary, I'm going to make some columns. Okay, the first case, of course, is the most commonly seen case, less than 2. Less than 2, okay? The absolute value is less than 2. The function perspective, right? And the next case, okay, I'm just gonna make a little adjustment with the picture. Okay, make a little adjustment with the picture so it looks better. Okay, so this is a less than 2. And we also did a less than or equal to 2, didn't we? So for less than or equal to 2, we did that too. Okay, so we did both perspective, right? So less than 2. And I'm going to put the number line there. Number line there. Oh no. So put it here. Okay. There you go. All right. Less than or equal to 2, right? So we have the function perspective. Okay, less than equals to 2. You see, we draw horizontal broken line, horizontal solid line, and less than or equals to 2. I'm just going to make a little bit adjustment there, right? And in each case, in this case, we have -2 less than x less than 2. And in this case, of course, the situation is slightly changed, and so it's going to be less than or equal. Less than equal. And we also have that nice little picture. We want to put it there for our comparison. These two cases actually are most commonly seen. But you will also see those other cases. Okay, you will see those other cases. For example, less than 0, less than equal to 0, and so on and so forth, right? We discussed less than 0, less than equal to 0, right? So for less than equal to 0, for less than equal to 0 case, right? For less than equal to 0 case, so what is our graph? We have that graph, right? We have that graph. Less than equal to 0. Where's less? This is less than 0, right? This is less than 0. So I'm going to put less than 0. Less than 0, less than equal to 0, right? So this is less than 0. So I'm going to put absolute value is less than 0. For our comparison, less than or equal to 0. Where's my less than equal to 0? Right here. Less than equal to 0. Right, we're going to put our summary right there. Okay, less than 0. Okay, and for number line, less than equal to 0, we have a picture, didn't we? We had a picture right here, right? We had a picture, we have a solution. We have a picture, we have a solution. Okay, so this is a less than or equal to 0 case. All right, and this is of course less than 0, right? So that picture is going to be, you know, that picture is going to be not, it's going to be empty. It's going to be empty, okay? So should I put that empty picture in there? I could, right? Let's put the empty picture there. Let's put the empty picture there. Let me just make the fonts a bit smaller. I think you can still see. You can still see, right? So this is less than 0. In these cases, right? In these cases, so here the solution is just x equal to 0, only one solution. Okay, and this one is what? No solution. No solution. If it's less than any negative number, right? If less than any negative number, okay, so let me put just one more column to symbolize that, even though we understand the scenario, right? If the absolute value is less than say, we did a -2, right? For less than -2, let me make the fonts just a little bit larger, right? Less than -2, we drew that line, and there's not beneath, right? The output will never be beneath -2, right? Less than -2, we have this picture, right? We have this picture. There's no touch. There's no touch with the existing outputs, right? There's no touch beneath the exist because it's not going to be there. Okay, but here you have to understand, no touch, you have to understand that no touch, the meaning of no touch here. The meaning of no touch here is basically your output will not be beneath this piece, not just touching. They don't show up beneath it. They don't show up beneath -2 because these are where if any vertical lines show up beneath -2, that means it's their solution, and none of our output will show up beneath the x less than -2. So it could be less than or equal to 2. We also covered that, right? So that one is less than or equal to -2. So we studied that as well. Okay. And so I'm going to put that over here. So for our comparison, okay, which is this case. And now we're ready to really do a nice comparison. Less than or equal to -2. Okay, don't forget its meaning. Okay, it's not only about touching. Okay, it's that not only there's no touch, it's not even beneath. We want that to be beneath -2. So we don't have anything like it. So we don't have anything like that. Okay, we don't have anything over. We don't have anything touching or beneath. We don't have these. We don't have these from the output of the function because all the output is measured from the origin. All the input is also from the origin. Output is measured vertically from the origin. Input is measured horizontally from the origin. Okay, so in all of these cases, okay, so there's no solution, no solutions. Okay, so let's see if I put it in 100%. So you see all of these pictures, right? In all of these 3 cases, no solution. You can see those, they show up in different shape and forms. In the other 3 cases, sometimes you have one solution, sometimes you have lots of solution, and the difference is whether it includes the endpoints. In this case, it doesn't include the -2, +2. In this case, it includes +2 and -2. Okay. I still need to make the fonts larger, otherwise you don't see the negative sign. Okay. So this is the summary of solving these inequalities. Wow. But once we understand this, what can we do about it? Of course, X could totally turn into baloney, right? These X could turn into baloney. In other words, X could be a complicated situation, right? Just like what we did earlier. So this X can be a baloney. This baloney or omega can be a complicated expression. It can be a complicated expression. Okay, so let me delete this row, these 2 rows, so it will be cleaner. Okay, so let me gonna write it back to the percentage as it was before. So it could be turning into baloney. So this could be turning into a baloney, okay, or a complicated expression. No matter what the complicated expression is, okay, no matter what the complicated expression is, and these are the models. Okay, these are the models. So all 3, it's really just one model, which is this guy. Because less than 0 include less than -2, include the next less than or equal to -2, right? So that's why if you are to study, right, being aware of what it means, it just takes you to go a long way. It takes us to go a very long way. It clear our mind about these questions and give us the wisdom to solve the questions, And of course, next we're going to do some more examples. Okay, instead of taking all these cases, okay, I'm just going to take these 4 cases, which covers all, right? And we're going to do some more examples. We can call these applications. Okay, so this is our summary. Okay, so once we have our summary, we can do a lot more. Okay, so let's look at some more examples. And last time the example was number 4 or 5. I could be wrong. Number 4. Okay, never mind, just number 4. So the next one will be example number 5. Example number 5. Solve for x. Solve for x, right? So here we have absolute value, right? We're going to work on these 4 types. We're going to have examples for these 4 types, right? Suppose I have a 3x plus 7, okay, less than 2. How about that? Less than 2. You can give any example, really. You can give any example, okay? And here, for convenience and reference, we just take, will be our type. This will be our type, right? So we're clear about the picture. We understand the meaning. So we just put that in our mind. You don't have to put there physically, but you have that picture in your mind, okay? So when you solve your solution, you don't have to show this table. But you have this table in your mind, okay? And if you like to put down that table on your, on your scratch paper, that's fine too. Okay, so what I do, right? I recognize this is the model, so I'm going to take this piece as my very first step, right? I'm going to compose my solution. I'm going to work towards my solution. I start to show work, right? So I have this model in my mind. I recognize 3x minus 7 plus 7 is my omega. And I got this inequality. After I got this inequality, I'm going to subtract 7 on both sides. So I got -2 subtract 7 less than 3x less than, I'm going to add 7 on both sides, subtract 7 on both sides. So it's going to be 2 minus 7. Okay, I'm subtracting 7 on all 3 sides. Okay, just make sure I didn't say anything wrong. Yes, I'm subtracting 7 on all 3 sides. And then what do I get? You make sure you done the math correctly. Subtract 7, positive 7 is gone, subtract 7. So then I will have a -9 less than 3x less than -5. And then what do? We divide every side by 3. So -9 divided by positive 3 is -3. And x is isolated. And -5 divided by 3 is -5/3. Okay, -5/3. I'm going to write a -5/3. That's it. That's our solution. You can see using these models, we can solve more complicated questions. Okay, so let's look at the use of second model. This will be our example number 6. Okay, I'm going to use my second model, right? And this question, we're going to do solve for x. Okay, and in this situation, we have I'm going to use a 2x minus 5 less than or equals to 3. How about that? I'm just making up examples. Maybe maybe I should do 2 though, right? Because I'm using this model. So this, it's a similar question, right? And I know the answer is this. I know the answer is that if I view 2x minus 5 as my omega, and my omega actually is 2x minus 5. So I started solving. I started to show work. I started to show work to reader, right? I started to show my work to the reader. Wait, what did I do? Let me do it over, okay? -2 between omega between -2 and 2, right? So I got that. And then I'm going to add 5 on both sides. So if I'm adding 5 on both sides, -2 plus 5 is going to be a +3. And that's less than equals to 2x. And then it's less than equals to, we add 5 on this side. So 5 plus 2, that's a 7. And then what I do, I divide every side by 2. I divide every side by 2. So 3 divided by 2, less than equal, 7 divided by 2. And that's it. It's finished. It's done. Okay, so how do you need to show the table and the graph? No, but you should have it in your mind. You should have it in your mind. Okay, the third case, example number 7, right? You find these very useful, these model very useful if you understand it. Okay, I don't want you to rely on memorization. Rely on your understanding. Okay, and this time I have an absolute value. Okay, 7x minus 5 less than equal to 0, right? I understand less than 0 is not possible, therefore omega must be equal to 0, right? So I start to formulate my solution. My solution says omega must be 0. So this is my omega, right? And then I'm solving for x, I'm isolating x. So 7x equals to 5. And the next thing I get, I found the solution. X is equals to 5/7. That's it. That's it. Okay, finished. And last but not least is this model. Okay. And on this model, wait. Yeah. This should be my example number 8. Okay, so I'm going to use this model. On this model, of course, we are aware of it. We don't need to show work, right? So solve for x, right? So what I have an absolute value of, 7x plus 8. Okay, if this is less than -5. If this is less than -5. Whoopsie, there. Less than -5. I have this model in my mind. I understand everything. So my solution, what do I say? My solution, my answer to this question would be what? This will never happen. This will never happen. I would say no solution, as you can give a nice reason. okay? You can say the absolute value of anything is greater than or equal to 0. You don't even have to specify what omega is. No solution. That's it. That's it. Okay. So this is the lesson for less than equal to, which is one type of solving inequalities. Okay, in the case of less than equal to, less than equal to 0, less than 0. Okay, and there are of course more cases there, but these 4 will be a good summary. Okay, this 4 will be a good summary. I will divide the. There's another lesson we're going to be dealing with larger than. Okay, so what's coming next? Right? What's coming next? What's coming next is going to be all of these are going to turn to larger than, equal to, larger than, equal to 0, larger than 0, larger than, etc., etc. Okay, so that will be the next lesson. Just to, make sure that you understand this, and I will see you guys. Well, I will see you guys next time. Thank you for watching. If you have any questions, don't hesitate. Bye.